Okay, so good morning, everyone. We were discussing syntactic processing, and the next topic that we have to start today is conditional random fields. So we had ended our lecture last time. We had discussed this IOB labeling technique under the name entity recognition. So let's discuss that what is conditional random field and how to utilize it to get the job done. So training an NER model from label data. So this is the kind of situation that we need to do. Uh, we will be implementing or understanding that how this thing works. For example, there are two sentences that I drove from Chandigarh to Patiala in Jaguar, and the second sentence is the deer ran away seeing the Jaguar, right? So there are two things here. So the first one is the vehicle, the second one is the animal. So the NER is best addressed as a sequence labeling problem, and one of the technique to solve this problem of getting this job done, that to understand that one is a vehicle and the other is the animal. So we will be using conditional random field to solve this. And what is conditional random field? Let's know the meaning of it. So conditional random field, it can be used for sequence labeling, and it is one of the class of probabilistic models. And there are two terms, random fields and conditional. So the meaning of random fields is that it's just that the probability distribution based machine learning model it is. And the second part, conditional, means that there is this conditional probability involved where p y given x. It means that x is the input sequence and the output will be the y value. Then the agenda is to understand that how this thing works, and how the model training has to be done for the CRF to get the job done for custom name entity recognition. So let's look at this example first. So in this example, let's say that we have a training corpus with these two sentences in it. Google Inc. is headquartered in Silicon Valley. The second one is I went to New York. Now let's consider that only the first sentence has to be taken care of. So we have taken word by word analysis of IOB. IOB was a technique that we saw in NER, and so Google is the beginning of the organization, and I is the in of organization. So it is in continuation that this is the company name, and similarly Silicon Valley, B location, I location. So beginning and uh, inside the location, right? So these are the outside values. So it is not to be taken care of. So it is not helping us in any form for now. So we will focus on Google Inc. and the Silicon Valley, which have got these tags of borg, iorg, and block and ilock. So in the training corpus, we will look at this first rule. Let's say this is our first rule, that we are looking at the input, which is x, and we will look at the words xi, xi minus 1. So whatever the word is and the previous word is, I is the location. So we will say it is equal to 1 if the first letter is capital, right? For this word, the first letter is capital and it is followed by small letters afterwards. So otherwise it is 0. So we are looking for word starting with capital letter. So it is kind of similar to regular expressions, but we get the gist that this is what we want to do. So this will actually help us to get the feature functions out of the training corpus. We have to generate multiple features. So we will look into it in some while, but this is how it should work. So this training corpus and feature functions will be the starting point. We will get some features, and then out of those features, we will look for iteratively optimizing the weights and finding out the scores of each combination of IOB tag. It means that, for example, we have this multiple options we have. So whatever the sentence is, for example, this is the sentence Google Inc. is headquartered in Silicon Valley. We have multiple options that can be correct to predict this name entity recognition, where in the first one we are saying that this is the beginning of the organization, this is inside of organization, this is outside, this is beginning of location, inside of location. So these two are being linked, right, by location. and organization. Similarly, in the second option, we are having something like this, that this is B lock. So this is location instead of organization, and I org, and all others are outside. Similarly, other options are there. So out of the four, we have to choose the best one. So clearly here the first one is the best one, but we will look into the process of it getting selected. And we will also assign the weights for each feature function. So we have multiple features. One of the feature was, we just saw that we want to put value of 1 where the first letter is capital and then others are not. So this is kind of finding the word starting with capital letter. So this is one feature. The other can be something else. So overall CRF should look like this. So once the model training is done, then the trained model with the weights such that the score of the correct IOB tag sequence has the highest score. So we will select the final one, the final prediction of this B org, I org, and all these things will be selected based on the comparison of all of them together. So this is the overview. So let's look at the model training, that how it works. So in order to train or build, consider the following sentences as the training corpus. And these two are the sentences. So we have just saw previously that we are saying Google, B org, I org. So all of the IOB tags are here. Similarly, X2 for the second sentence, it is like this. So where ORG and LOC are the organization and location respectively. So let's look at this, that to get the job done for model training, for a better understanding of the end-to-end process, we are considering only two tags for now because it is easier to explain and also to understand using only two tags instead of, let's say, 37 tags or maybe 15 tags. So we are not having that complex tags as of now, just for the sake of understanding. To simplify, let's consider only sentence x1. So we are saying that x1 is x because we are only considering the first sentence for understanding purposes, but there can be multiple sentences. You can pick any example out of those. So to simplify, let's consider this example for O, org, and loc. There can be multiple combinations of IOB tags possible for the model sentence x1. Some of them can be written as this, as shown in this table. So for the input sequence x, there can be multiple combinations. So what we are trying to say is that where there are multiple options, right? There are multiple tags that might come as the output, and we need to select the best one. So this is how there will be multiple options based on multiple types of features selection, and we have to choose the best one depending on whatever the highest score is for the correct combination. And we will look at that how we are calculating this score that we are talking about. So how the model calculates the score, it will use the idea of feature functions and weights to do that. And I will go into the depth of it now, that how these feature functions, weights, these two are together helping us to get the best score out of it and understand that what is being done. I hope सबको समझ में आ रहा है, right? If you have any doubt, you can write in chat box, or you can stop me in between. So commonly used features in CRF for NER. So we want to look at multiple types of features. We had only covered one feature. अभी हमने थोड़ी देर पहले सिर्फ एक ही फीचर देखा कि फर्स्ट लेटर कैपिटल है तो बताओ कि मतलब वन है, अदरवाइज नहीं. बट देयर आर मल्टीपल टाइप्स ऑफ फीचर्स. सो लेट्स सी. You can build logic on input word xi and on the surrounding words, which could be xi minus 1 और xi plus 1. सो हमें ये भी देखना है कि अगर सराउंडिंग वर्ड्स के थ्रू हम देख रहे हैं तो उसके बेसिस पे हम कुछ बता पाए. द प्रीवियस टैग ऑफ द वर्ड xi एंड द सराउंडिंग वर्ड्स प्रीवियस टैग के बेसिस पे भी कर सकते हैं. एंड वी कैन ऑल्सो लुक फॉर ए डिक्शनरी. फॉर एग्जाम्पल, if you are into organic chemistry, you are working on, let's say, some chemical reaction, नॉर्मल डिक्शनरी में वो वर्ड्स नहीं मिलेंगे. सो हमें ऑर्गेनिक केमिकल वाली डिक्शनरी चाहिए होगी. सिमिलरली फॉर बॉटनी एंड और एनी अदर मेडिकल डिक्शनरी. सो बड़े स्पेसिफिक डिक्शनरी होते हैं. वी नीड टू फाइंड multiple dictionaries depending on our use case or vocabulary, right? So we need to select that particular dictionary and we need to work around that. Word shapes. So this is how the dates can be ruled, right? So DDD here means digit, XXX means the character. So यहाँ पे we can see that 26/3/2021 or 26 MAR 2021, we are saying that in this MAR March, the first letter is capital, others are small, so XXX should be like this, and all of them are being written in a way. So you can also maybe find some prefix or suffix such as doctor or LLB. So if someone is lawyer, they will put a LLB at the end of their name. If someone is a PhD or a medical doctor, they will put DR dot in front of their name. So these prefix and suffixes will help us to understand that what kind of features we are trying to build. There are multiple options. You can choose any way to build your features. So understanding of features and how the model maximizes score for the correct tag sequence. Let's consider the training dataset again. So this is our training dataset and this is the first thing. So the first part of any model training activity is to have a training dataset. We have a training dataset in which each token is manually tagged and the correct tags are shown in red in the table above. So this is the table. So there can be many possible combinations. You can put multiple combinations, obviously, right? Maybe some random allocation or maybe some different rules, but trying it multiple times might give you multiple answers. So we will have to verify that which one is the best one. So that's how it is being done on the back end. Now the next part of the model activity is to have some features to feed into the model. So obviously we will be feeding our machine learning model or deep learning model some features or embeddings, right? We will be converting all the words with different features and then depending on that particular column. So let's say that I want to send this sentence as an input, so I will put 1101 something like that, right? So let's see that how it works. So now let's consider the three features. Let's discuss these three. The first one is the same one, the word starting with an uppercase letter, so XX plus. I have already told you the meaning of this. The second one is that we want to look for a continuous entity, that first and the second word both are noun. So if this comes up, this is a continuous entity. And if a company names come up, you can say that the XI is Inc. and the one word lesser than that is the beginning of the organization. For example, Google Inc. or Facebook Inc. Something like that. So generally INC incorporation is company name, part of company name, right? It can be private limited, it can be anything else, but generally for this case we have taken only incorporation example. So there will be multiple weights that will be assigned to F1, F2, F3, different features. Multiple weights will be assigned, let's say 1, 2, 3, and we will have to do some processing based on that. So we can elaborate the definition of the feature function as follows. So we have already seen those three features on the previous slide, but this is how it looks like. The feature one indicates that if a particular word is in a given sentence, it starts with the uppercase letter, then assign 1, otherwise 0. The feature 2 indicates that if a particular word in the given sentence has a POS tag of noun and the word before it also has a POS tag of noun, so both the words, whatever I told you in the previous slide, and then again this include incorporation, the organization name, based on that also you can do some feature engineering. Hence, the model considers all the possible combinations of the IOB tags uh, of the given training sample, and it calculates the score of each combination. So we will be calculating the score, and the model will start the computation by taking any random initial weights. Let's say 1, 2, 3, something like that will be given, and for each feature function, and iteratively modifies the weights until it reaches a stage where the score is the highest. So we will look it at as an example now. For example, I have this sentence and I am giving this, I'm taking this as an example. Okay, bhai, I have to work. For example, my first IOB tag has come up to be beginning of a location. Obviously we wanted this could to be organization, but it is saying that okay, location. So because sometimes we say that Google it, right? Google some location. So this is kind of a probability. There is a high probability that block can also come for Google word Google. So block, iorg, and all the others are outsiders. And now if based on these two only we will make some decision, right? So for this XX plus the word starting with an uppercase letter, we will look for all the uh, words in the sentence, and we will say feature one has to be one if my rule is this, that the first letter is capital and others are small. So first, second, six, and seven. So these are the four features that are these are the four words which are having the F1 value of one, because all of these four words, one, two, six, and seven, all these four words are starting with a capital letter. Similarly, if we want to look at if two words are consecutively noun, right, then we will say that my current word is noun, because if my previous word and the current word is noun, then only we will say that the current word is having the value of one. That's why in this case only valley is having one, otherwise all of them are having zero, because uh this was not a noun, right? So depending on whatever the tag is, pos tag, we can make a decision about features in this case. Third one is that if we want to look for the company names, often end with the incorporation. So depending on that, we will say that all of will have zero, because the previous word Google does not have the B organization tag. So if the Google had B org tag, then I org would have had one, right? Based on this rule. But this is having zero only because this the first prediction is B lock, not the B org. Location Bravo, it should have been organization. So all of them are having zero. So the final one becomes like this. So this is how we have calculated the three features, 1 1 0 0 0 1 1, and similarly for others. Note that we are not covering the optimization of these weights. Whatever the weights are, it will work similar to gradient descent algorithm that we have already seen in the starting lectures in this subject. So let's consider the final optimized weights calculated by the model after many iterations, and let it be W1, W2, W3 corresponding to the features F1, F2, F3. And let's say that this W1, W2, W3 is having 1, 2, 3 respectively. So based on that, what we will have to do is we will have to calculate the values of scores corresponding to each of the combination of NER tags. So we will find the scores of each feature. So let's look at it. Now feature 1 into weight 1, feature 2 into weight 2, feature 3 into weight 3. So whatever the numbers were, they will be multiplied by these weights. So because in the second column we had 1 at valley and all of the others were 0, so that's why we have multiplied it by 2, and my column sum is 2. Similarly multiplied all of these 7 values by 1 only, so the total sum is 4 for this column, and similarly the last one is having 0 because all of them were 0. So the value of the score for this combination is 6. The weighted feature sum is 6. So now let's consider another combination of y, the second version, and this is how it will look like. For example, I have taken the second option jahan pe we had b lock, I lock, b lock, I lock for all the four words. So based on that, whatever the values would be, it will be 1 1 0 0 0 1 1. Similarly for others, and multiplying them with the feature weights, we will get the values like this, the red column. Summation, it will give me 6. Similarly for the third part, if I do a b org, I org, b lock, I lock. So based on that third rule that I had to work around, we will work around all the features depending on these initial IOB tags. So the summation is coming out to be 9. And we can see that obviously out of the three, we are having the best score in the in this case, by case, right? And so you can do it for y1, y2, y3, but we have compared instead of y3, we are comparing here the original one, the first prediction, right? So there were total four options in the beginning. So we had looked at these four options, right? There were four options: y dash, y double dash, y triple dash. So we have now calculated the values of y dash, and y double dash. This one is coming out to be 9. These two are coming out to be 6. So this is the winner, right? Depending on the score value. Now, so as you can observe, the score of the correct NER tag will be 9, which is maximum along all the combinations that we have considered. So this is 9. Good. So now that's all for this topic of CRF. This is how we need to do the calculations, and we need to calculate the scores about how the things have to work for different kind of features. So features can be many. We have only considered three. Instead of incorporation, you can also do it for private limited or something like that can be done at multiple scale. But it's on you that how you want to do the feature engineering. So that's all about this topic about syntactic processing. Now we will move to the final topic of the syllabus, which is the semantic analysis. So I'm bringing you to this topic. Just a second. Yeah. So semantic processing is one of the very important part and the advanced version compared to lexical or syntactic processing. So let's see that what we will be covering in this before ending the syllabus. So semantic processing, may we have knowledge graphs. We will discuss WordNet, and even we will see other types of it, other types of knowledge graphs. We will be discussing about the distributional semantics, where we will be going into the details of geometric representation, cosine similarity, bag of words representation, word to vec, or even this C bag of words, right? So the topic modeling is also one of the very famous topic in the domain of natural language processing. So we will be covering all of these one by one. Today I will be trying to cover the knowledge graph to some extent, and maybe if the time allows, we will look at the uh, code also for WordNet. But I will prefer that because we have covered few things about the syntactic also. I will try to cover the theoretical part today. We will start with the coding of WordNet in the tomorrow's lecture. So the recap of syntactic processing is we have already studied in the previous topic that we have considered. So the part of speech tagging, hidden Markov models, constituency and dependency parsing, name entity recognition, custom NER and CRF. So we know the details that how this all of these syntactic processing techniques work. Now, syntactic processing involved the study of grammar to understand the meaning of sentences, right? So, however, there is no single encompassing rule that will define the grammar, because generally what happens in real life is also that uh, we as humans, we don't care about much grammar when we are speaking, right? Even the best of the speakers will not use the perfect English grammar to convey their words, and the best speakers are known for content and their vision and not for the grammatical things. So grammar should not be a big issue when we are building a machine learning model. So it will be better if we can actually build our models in a way that how our human brain works. So the text data is generated, जो maximum हमें text मिलता है online, all of that is not perfect, and maximum of them have grammatical incorrection uh, as a raw data. Obviously you can improve through the spell correction method and other techniques, but generally raw data is having so many of issues. Even spelling mistakes are there on online social media, and uh, lots of people use slang language also in their YouTube videos. So if you are working on, let's say, video captioning, so that there will be multiple issue regarding that, because your models will not identify slang, because you might not have those words in your dictionary. So we have to be very careful about how we process the things and how we understand the context. So we have to be better at building our models. However, we do not rely on grammar to understand the language. As a child, uh, we did not care about much grammar, and we used to just convey our message, right? Even today, if I say I is an assistant professor, it means that I am an assistant professor, I wanted to say, but there is some maybe typo error or something like that, but the meaning is conveyed, that I am assistant professor, I'm doing a job with this tag. So although this is grammatically incorrect, we can understand it perfectly. It could have been uh, I is a cricketer, I am an cricketer. So uh, many many sports person are not perfect in speaking English, but we respect them for their work and not for the language, right? So this is how the vision of syntactic, the semantic processing comes along. So need of semantic processing is that semantic processing is probably the most challenging area in the field of NLP, because the concept of meaning itself is very wide. Uh, for example, we want to detect some sarcasm, online sarcasm, right? We might be need to deal with the synonyms or antonyms, all those kind of things. We need to understand, our model should be able to interpret that what is being said, and is it in the right way of writing it. For example, I am writing TIET, right? For example, I am saying uh, TIET in some text, versus I am writing TIET like this. So my model should understand that I am talking about Thapar Institute of Engineering and Technology, and generally we will make a rule for this one. It can be easily done to make a rule that, okay, if all the words are capital, right? If all the words are capital, then this word is my acronym, right? So this is acronym, but for this one, this is not a normal way of saying it. So even this need is one of the word which is having all the characters, right? This is character 1 2 3 4. Similarly, if I am writing TIET, it is a acronym in itself, but again we would say that these are different characters. So is it a simple word or a acronym? It will be difficult to detect. So there are various challenges that we need to take care of and work around. That's why we, whenever let's say that you become data scientist, or you have that responsibility that you have to build something for your client, you will need to read some research papers, because research papers are actually the best tool to understand that how to solve these problems. Because not everything can be taught in a 50-minute lecture, or even in a 40 lectures course. You will need to update yourself to get the things done practically in the real world at your jobs. So dealing with synonyms, dealing with acronyms, dealing with the sarcasm, all of these things will have a challenge, and it can be done through semantic processing only. However, we rely on the meaning and context, so we need to do some semantic processing. So I also want to highlight one more thing. Initially, in years till 2016, the deep learning models were RNN based. LSTM was one of the model that was very famous, that came around 1997. There was a GRU model that came around 2014, and these three were kind of superstars in solving NLP problems. But in 2017, I guess late 2017, the transformers came, right? So the transformers are deep learning based models only, but they focus on the attention. So the context is able to be understood using the transformers and its variation. So there are multiple variations of transformers. There is BERT model, there is robot, Roberta, I guess. This is the full name, Roberta. Then there is Albert. Then there is a variation of BERT called XLMR. R is Roberta here. This is cross-lingual language modeling, something like that. There is one more, latest one is Palm. So this is the Google research based model. They have trained their Palm model on 570 billion parameters. So this is a very big deep learning model that they have tried to build and forget the generalization. Actually, I will tell you that Palm model has been built to explain you the jokes including sarcasm. So whatever we are writing, let's say I'm writing few words and I'm joking in this sentence. So this sentence needs to be understood, or maybe let's say that we sometimes ask our friends that can you tell me the meaning of this, this looks like sarcasm but I'm unable to get the exact meaning. So the explanation of that joke is done through this model, Palm Google research model. So you can maybe search about it has come around first week of April this year only, April 2022. Only 1 month old this model is. So you can search about these things and have a better understanding on your end. But there is a very highly motivated team of researchers in high quality labs which are actually trying to solve these kind of problems at a large scale. So the agenda one of this topic of semantic analysis is that I will be discussing about the introduction to knowledge graphs, and we will be discussing about different kinds of knowledge graphs out there, applications of that knowledge graph, that what are different applications, how people are working on it, what is wordnet, we will look at a demo of it today, and word sense disambiguation will also be covered in the lecture. So today I will try to give you the overview because we have only last 10 to 12 minutes left, but then the understanding has to be very clear. So a graph data structure consists of a finite set of vertices, right? We all know that. This is a very basic data structure definition. And this vertex is also called a node or a point. So, but they are connected through edges. And that edge will actually give you the meaning that how the relationship is. So in the case of semantic processing, the text data is aggregated on graph based data structure. In the knowledge graph, entities are represented by nodes, where some pairs of the entities are related in some sense. These relationships, these relations are represented by edges, right? So we all understand that how this thing works, and it will be something like this, that there are multiple nodes and there is a edge which is actually telling us the relationship. So these are, and this is entity 1, this is my entity 2, and this is how the relationship is. So this is the basic agenda and this is the basic understanding of how this knowledge graph works. So let's look at this diagram which is giving me understanding, basic understanding of how this knowledge graph works. So if I'm talking about a philosopher, I would say Plato is a philosopher, Aristotle is a philosopher, and the philosopher is a human. So Plato was born in Greece, Aristotle was born in Greece. Athens is the capital of Greece, and Athens is a place. So relationships have been built like that. Can anyone tell me that what are the different examples of this kind of relationship? Can you imagine if you are working on, or maybe you have joined some website which is actually using this uh, concept on its background? Can anyone tell me? Obviously, I've got the answer in chat box. Uh, Facebook, right? Facebook, LinkedIn, all the social media apps. So when we are connecting to different people, first friend, second friend, or friend of friend, so second connection on LinkedIn, third connection on LinkedIn. So those kind of connections are built on knowledge graph example only. So you can see that the different types of entities which are human, occupation, names of people and names of places are there in this. The different types of relationships are is was born in, is capital of. So these are the relationships. So this is a simple representation of graphs. However, graphs are generally very complex structures, and obviously there are multiple examples of it. Let's discuss few of them. Right, I want to give you the detailed understanding of how this knowledge graph works. So let's say that uh, I mean, these are the four famous knowledge graphs that we have knowingly or unknowingly worked around, or maybe graph. Google search is the, I mean, kind of a daily use thing, right? So knowledge, Google search is actually working through knowledge graph only. So I will give you the basic understanding that how this Google search is actually implementing the knowledge graph on its end. So let me take you to google.com. Just a second, switching the screen. So if I search about, let's say, some author, right? So maybe I'm searching for some author, um, Robin Sharma. So Google knows that he's a writer, and there are some books that he has written, right? So there are some books that he has written, and there are some movies also, uh, which is actually maybe using his books, right? For example, uh, I mean, movies are there for, I mean, there is one writer called I'm unable to recall the name, but Three Idiots was built uh, over that book by Chetan. uh, so Three Idiots was built from a book, right? Three Idiots book, let's say, let's find it. So I think it was 5 point someone. The book name was 5 point someone, novel by Chetan Bhagat. So this book was actually converted into Three Idiots movie. They must have changed few things, but this is how the things were. For example, now let's talk about this Robin Sharma, or maybe Chetan Bhagat. And Chetan Bhagat books are these and movies are these, right? Half Girlfriend. So there are few movies that have been made out of Chetan Bhagat books. So the first thing, the query was the name of the author. So the Google gave me the basic information about this person. Then books, which books he has written. Also the movies. Now if I click on movie, let's say Three Idiots, right? So it will also show me multiple example of other movies around those time era. So this second movie is also around the same era of this Two States and Kick are out of 2014 only. So then the cast also, so multiple things are connected. Book is connected to movie, right? Movie is connected to cast, and cast is connected to their other movies. So there are, I mean, other things, right? The songs, the movies, or the person, or the news related to that person. So Google is actually giving us all these things based on the knowledge graph built on the backend. So now let's talk about the WordNet. So the Google search is actually using the knowledge graph, and we are able to understand what is being done around this. Now the different types of knowledge graphs may, WordNet is also one of the very famous one. So let's look at the WordNet example. So I have put multiple examples also here. So let's discuss these first, and you will automatically understand that what are those names that I have written on the previous slide. So suppose you need to understand the text data that is related to the medical field. Now, if you use WordNet or ConceptNet, they will not have the medical dictionary words, right? We know the famous knowledge graph called Google search. Maybe you can search around that. And even some other companies, I mean, companies like Microsoft, Facebook, IBM, eBay, all of them are having their own knowledge graphs on the backend, based on which they are building their networks or even doing a search engine, right? IBM is a it provides the framework for other companies to develop internal knowledge graph. IBM is providing that kind of service to the different industries, let's say healthcare industry. So maybe you will find healthcare knowledge graph platform by IBM. I'm not 100% sure about it, but if IBM is into this business, there is a high chance of this thing. Now eBay is currently developing a knowledge graph that functions to provide connections between the user and the products present on the website. So the WordNet, let's discuss about the WordNet in detail now. WordNet is a part of NLTK, and we have already used it. We have already used it in the initial lexical processing coding through NLTK, but we did not dive into the depth of it. So we will be using this for the word sense disambiguation that I have discussed in the initial slide. WordNet is a large lexical database of English words developed by the Princeton University. It can be accessed on this website, wordnet.princeton.edu. So nouns, verbs, adjectives, all of those things are there available. Now let's go to this website and let's look at how the things are working around here. So I will take you to this page. Just a second. So this is how it looks like. This is the web page on which we have landed on clicking that link. So let me search about a word called bank. I will write bank here. So for a bank, it is giving me multiple senses that it can be in terms of noun. Multiple examples of noun are there. Then also there can be multiple senses in terms of verb, right? So the pilot had to bank the aircraft, bank roads, enclosed with a bank, do business with the bank or keep an account at a bank. Where do you bank in this town? So there are multiple variations of this word. And this synset is giving, I mean, we were saying that this is sense. So synset is actually the word, the exact word, and synset is the synonym set of this thing. So the wordnet is giving us the synonym set of different words in terms of nouns, verbs, or any other kind of sense. So they provide us these things. Now, relationship between senses. So there are multiple types of relationships that can be there for the senses. So the relationship between different words can be grouped as follows: synonyms, antonyms, hypernyms, and hyponyms. So I'm going to give you the example. For example, for a synonym, large is synonym of big, right? Big and large are kind of similar and they are called synonyms of each other. And large is antonym of small. So everyone must be clear about synonym and antonym. I will not go into the detail of it. But then hypernym and hyponym is kind of new word for many of you. So a relation between a concept and its subordinate. A superordinate is all encompassing. For example, now fruits is the hypernym of mango, right? So mango is a fruit, but we can't say that all the fruits are mango. I hope you understand. So fruit is kind of the parent of mango, right? And this fruit can be even apple, it can be strawberry, so it can be any fruit. So fruit is the superset. So in this case, hypernym means that who is the father, who is the root node, right? Similarly, the hyponym means that a relation between a concept and its subordinate. So apple is hyponym. So if I'm saying fruit is the hypernym, so apple is the hyponym of fruit. So it is a subset. So these are the meanings. The other thing that I want to discuss is holonym and meronym. So holonyms are relationship between a whole and its part. Face is the holonym of eyes, right? So because eye is the part of face and face is the holonym of eyes, so they are linked with each other. And relationship between a part and its whole is the meronym. So whole here holonym is the superset and all the subparts are the meronyms. I hope you get the meaning of it. We will look at the WordNet code demo in tomorrow's lecture as the first thing. And because the time is up, I want to end the lecture on time so that you can go to next class. Thank you. I'm stopping the recording now.